Gravity. Ah, gravity. She is a harsh and fickle mistress. This object, formerly known as a lamp, has come in quite handy before. It's actually a neat little thing of 2 panels, and you can turn on 0, 1, or 2 panels at a time, and they individually flip up. So you basically have these little walls of light. I don't know if it's LED or not. I think it is, but I might be wrong. The little bulbs have little yellow spots in them. But as is sometimes the case in life, one must make the best out of a bad situation. If we won't be able to use it in this form anymore, we may as well take it apart and see if we can use it in another. So let's begin the teardown. In a side spot of good news, I have a new camera coming in the mail. Now, I can't guarantee it'll be any good. I hope it is. It's manufactured by Canon, which is a reputable brand. So hopefully within the next week, this stream will start looking like an actual production rather than a back alley bootleg. But in any case, we'll make do as we have for the moment. So the first thing that's obvious is there are red and blue wires that are hooked to screws. You might see that this lamp, these are the light panels, and there are 4 poles here. The battery compartment's down here, and these panels flip up and down like this, hinged at the top away from the battery. So it looks like the power is conducted either through or by these poles. So the first thing I'd like to do, well actually, the first thing I'd like to do is cut this wire. It was the last wire holding it on. And if I look inside this pole, you've got the red and blue coming out of it. So one clearly is positive and one's negative. Because it's battery powered, it's DC operated. Both of these go into the panel here through a hole. And that doesn't want to come out, so I assume we have to disassemble that first. But this is how it was hinged, so it would turn. And now I need screwdrivers. I don't know how, but over the years I have accumulated a large number of screwdrivers. And somehow 95% of them are flathead. Don't ask me. But let's go ahead and disassemble, using a smaller screwdriver, one of these light panels. And hopefully this will answer the question of, is this an LED panel or not, if I can get a closer look at these bulbs. Either way, I should be able to repurpose the panel. Now, it's a lamp, and you could only turn on one at a time of an entire panel, so I doubt it's going to be wired in any way that I can just adapt to individual control to turn this into some sort of matrix display, but we'll see. So I look in here, and indeed, we have red and blue wires. You can see there are what looks like PCB strips, so the lights are connected in columns here. And whenever you're operating something like this, always be careful of capacitors. This has been off for a very long time, but the batteries were still in it until yesterday. So just watch out for capacitors that could still be energized. In order to discharge a capacitor, just take a nice resistor and short across the leads. So that should remove, the front casing of the panel, exposing the actual bulbs. I do not know how this is hooked. There we go. So this is the top of the hinge, and I have what looks like center spot and then a ring around it. May or may not be able to see that. So one of them is probably the positive and one the negative, if I had to guess. I'm able to pull it out, and indeed I see a spot of solder. So yes, it conducts its power, one through the middle and the other through the ring. And so that's how it managed to be rotational without the wires always getting twisted. It went from wires to this circular metal conductor back to wires. So at the top we just have 2 little metal springy bits that transfer the power back into red and blue wires. Let me see here if I can pull a board out. There we are. I'm still not sure if these are LEDs or not, but there is a big old power resistor right there. So it is a PCB, and it just has one single trace going down the line. So the PCB was used mostly for rigidity, I would guess. So it looks like I can pull out all of these boards from the little housing here, trying to not snap them. There we are. And the middle doesn't want to come out. It's being stubborn. There we are. So now we can see, first of all, a giant scorch mark, so that's nice. I don't see any visible damage on the LEDs, or on the bulbs I should say, but clearly something was damaged here. It wasn't even on when I dropped it, so I doubt it could have been a short. So we've got 2 wires coming from this little PCB here. Not sure if I can pull that out. Sure can. So that's just the casing. So we have this little PCB here that transferred the power back to wires, And then right here at the start, one of the wires goes into this giant power resistor. It's called a power resistor just because it's intended to dissipate a large amount of power. And just by the size of it, you can tell that's why. So one of the wires goes into the resistor, the other comes out here. So we can see the power is conducted down the trace through the middle and this one, and it basically goes around and back up, and that wire connects back to the second wire. So there's our circuit. Now, before we go further, let's go ahead and look at the power situation. So in the battery compartment are 3 D-size batteries. Now, we've established these are still 1.5 volt, just like the little ones, but they have a much bigger capacity, which makes sense because this is supposed to be a nice long-lasting lamp with a lot of bulbs. Now, how are they hooked up? So we look in here and the lighting is probably completely inadequate, so just take my word for it, but there are springs. Wherever there's a spring, see there's 3 springs. The spring connects to the flat side, that's the negative side. There will be a flat piece of metal with a bump on it. That's where the bump on the positive side goes. So a spring touches here and a bump touches there. And so if we look at where the springs and bumps are and where pieces of metal are connected, we can see that the negative of one battery goes into the positive of this one, battery 2 I'll call it. The negative battery 2 goes across to the positive of battery 3, and the negative of battery 3 is here, whereas the positive is back there. So these 3 batteries were connected back and forth, but effectively in series like this. So it was not providing any more current, but it was providing more voltage. So we now know that this was a 4.5 volt supply, roughly. So if I turn my power, let's say, to 4.5 volts, so let's turn my power to 4.5 volts. And now, remember to have the current set to 0. I'm actually going to... Actually, I'll just do it this way. Now, the key thing here is that I'm not going to be touching it when I do this little experiment. So I'm going to use just a little piece of plastic there to hold it down, and I'm going to take the power supply wires. Let's shove that a little bit over there. Now I'm going to turn the current limit up to, let's say, 5 milliamps. All right, so right now it's doing 0, but if I connect them, you can see it'll draw 5 milliamps. So I'm going to touch across these 2 panels and see what happens. Aha! We have quite a spark, and they come on. So it's limiting the voltage to provide those 5 milliamps, and if you notice, they're flickering. Now let me do it the other way. If these are LEDs, the other polarity will not work. And indeed it does not. There are no other components on this board. There are no capacitors. There's no nothing on here. There is a resistor, and then there are the bulbs. So because there is no possible circuitry, no diodes of any kind otherwise, that could cause that polarity, you know, to only go in one direction or the other, that means these are indeed LEDs. Now the interesting thing is I'm connecting it through its normal power here, which is going through this resistor. Let's measure this resistor. How big is this resistor? Not as big as the mess on my table, but this resistor, if I can connect across the leads, I'm getting crazy, wildly varying values, which means I don't have good contact with the leads. Ideally, I would just rip this off the board and measure it that way. So that's good contact. So the 2 mega ohm was too high. Let's try kilo ohms. Try to make nice good contact. And yes, remember this is unplugged. Measuring resistance, you need it to be unplugged, and it's safe because there's no capacitors. So if I make nice good contact with this wire, or attempt to, let's connect to this lead down there and try to touch this one up here. Let's turn it down even more. I figured it would be a large value resistor considering how many LEDs it's going through, but it seems like it's not. Now that could be a problem. I'm getting a resistance of 1.6 ohms across this huge resistor. Yeah, consistently. So what it seems like is this resistor is shorted. And if we recall, batteries have an internal resistance. So it could be that. It could be that this resistor was just a little auxiliary, perhaps to control the voltage level, whereas the batteries themselves, it was relying on the internal resistance of the batteries to not overload the circuit. So there we go. So I will now put this separately, and I might be able actually to turn this into some sort of grid display. I might have to desolder and resolder everything, but free LEDs, well, free so to speak, they came out of a working device. So the other panel I assume is going to be the same. Let me go ahead and turn the power off. So we've seen how the display itself works. We've seen how the batteries are hooked up. Let's go ahead and see how these poles are. I'm curious, is there a wire that goes through this pole, or is it actually conducting the power through the pole itself? So where this one is connected, now there is a little plastic tab of some sort. So let me take this off while holding the wire. This may be like a screw terminal, and indeed it is. I take the screw off, and there are two blue wires. Perhaps you can see these little rings. There are metal rings. So that's what the tabs were. It was just part of the metal that I thought was plastic, but it was just how it was reflecting. So it looks like the power is actually being transferred directly through these poles. Raw power right here on the metal being touched. And that's not terribly dangerous because due to the internal resistance of the batteries, the amperage is not high. And the human body's resistance, even when the hands are wet, is not super high. So, for example, 4.5 volts, if I go ahead and turn the current limit up to 5 milliamps and go ahead and touch both poles, I'm touching them both with the same finger right now. It's not even drawing a milliamp. It's not even getting warm. As I illustrated in my touch sensor video, there are microamps, perhaps 12, perhaps 6 microamps going through my finger right now. But I still don't like it. Just because it's safe, relatively speaking, doesn't mean it's as safe as it could be. Certainly cheaper that way because you're combining support and wire. But if you drop this thing into a bathtub, again, the batteries are limited in current, so you're not going to be electrocuted. But if you were to drop this into a bathtub, it would short quite nicely, and it would be draining the batteries at maximum draw. So while it wouldn't kill you, it would still be just a not great way to design it, in my opinion. Perhaps the industry disagrees. But another thing, this reminds me, a common thing in cars, in vehicles, is, for example, you have to run power to your rear lights and all the lights all over your vehicle. Oftentimes, the chassis itself is used as one of the wires. So you only have to run one wire back and forth throughout the vehicle rather than two. So it saves on cost. And it's also safe. If there's a short, it's shorting through the chassis of the vehicle itself. That is a lot of metal. That is a huge amount of metal. And electrons love to spread out. So if you short a ton of electrons into that chassis, they're going to just spread everywhere. And by that time, fuses have blown or batteries have gone bad or whatever. So it's a similar idea. Let me go ahead and unscrew the red wire, but I'm predicting that it's going to be the same thing. And indeed it is. When I take this screw off, we have, on the red wire, another little ring. Now the interesting thing is there were two blue and one red, but I think the other one may have just gotten ripped out. Oh, and yes it is, okay. It got ripped out in the fall. I see a tab where there's a metal ring here that no longer has a wire attached. So presumably there were two red and two blue. That would make sense because that would be a positive and a negative for each of the two panels. Now the final thing to check is the switching mechanism. This is a push button switch, as you can hear, but it had 3 settings: off, 1 panel, and 2 panel. So I'd like to see how it managed to do that. The bad news is, it looks like I'm going to have to physically rip this apart, but before we take drastic measures, let me finish unscrewing the tops from these poles, because perhaps the poles themselves unscrew. Come on, you beastie, bend to my will. Well, there goes gravity again. See, I told you. So here are the 4 poles, and they are not turning at all. But you can see there's no wires. They are hollow, but there's no wires. I'm trying to keep myself in frame. Please forgive me. I'm new at this YouTube thing. I will get better with time, I promise. So I would almost like to keep this battery chamber intact, as I could use that in the future. But let's not get too greedy, because I still want to see how this works. Yep, this is probably snapped in somehow. Probably glued together, so I don't believe I'm going to be reusing this one. Woo! Perhaps I should have been using eye protection. This time I'm going to do that away from my face. So I look in here and I can see the other screw hole for the poles, and I can see the blue wires. So on one side is the blue wire, so this side should have the red that connects to one of the poles. And it looks like even ripping this off, I'm still going to be able to save the battery chamber in some form. I would love to get a 3D printer, then I could just make these myself. Perhaps someday. The costs keep coming down. But right now, not having an unlimited budget is definitely not the right time to buy one. The longer you wait, the lower prices will be. If I can tilt this up, perhaps needle nose pliers are a better tool. And indeed they are. It's almost like we have different tools for different jobs for a reason. So yes, I've made a right mess of it, but there we are. And I was right. Down in there is a red wire to a screw terminal. Down there is a blue, and they screw into these. So if I can get my screwdriver down that far, I can get these poles off. Yep, and they're turning. Now, this is the kind of thing you should hang on to if you disassemble a device like this. Just a random little metal pole, stick them in a little plastic bag, stick them in a drawer somewhere. This is the kind of thing that is randomly going to be useful someday. And if you want to buy these, like, you're going to have to search around who's got the right kind of pole, just the right length, and in principle, they shouldn't be expensive at all. But just save yourself the hassle. Don't be a pack rat, but keep a few things. It may not be worth it to keep an entire box of random screws over time, but nice metal poles, hang on to them. So now, one screw, the other one is not cooperating, but I won't take no for an answer. I refuse to be thwarted, but let me get the other poles out, and I'm not sure how this battery chamber itself is secured in there. It does look like it's most likely glue. So I think I'm going to go ahead and just break it out. As much as it would be nice to reuse this, I am far more interested in that switch. Aha! See, I should have looked before resorting to violence. I have found 4 more screws. There's always another screw. And clearly these were screwed in before the metal parts were added, because they're awkward to get to now. But if I take that out, and if I had noticed them earlier before I started ripping out pieces, I would probably have a whole working battery chamber right now. Sure enough, it's coming right out. Well, I can still recover it. I did not completely destroy it. It'll be messy, but I can make a new housing for it. But we can see here is the switch. So on this part is just, indeed, a little rubber button that transfers the force through the case, which is now empty. And in here is the final screw terminal that didn't want to come out, a red wire, that connected to the poles. But here is a tiny little PCB with this switch. Let's take that out. Let's preserve the wires. And I can see it is a 4-terminal switch, it looks like. Yes, indeed. So we just have a small little PCB with the switch on it, with wires coming off. Presumably one of them was the negative, or perhaps it's unused. Or actually, it looks like a trace, it's shared. So it looks like this is using 3 of the pins, and 2 of them are shorted together. I look forward to desoldering this and seeing how it works internally. Let's check the height. Let's watch the height of the button. It looks like the height of the button is indeed not changing. So there must be some sort of internal thing that's moving. So that'll be an awesome thing to figure out. I'll definitely do a future video on that. And in the meantime, that's going to be it for this teardown. So I have gotten myself a nice 3D battery, so 4.5 volt battery chamber that I just have to solder some wires on more properly. Fortunately, I didn't rip it apart more than cosmetically. I recovered a bunch of LEDs, which right now I could control separately because each PCB has 3 of them on there. So I could make some sort of animation where I have these in rows and use a shift register to control 3 at a time. I probably will not desolder these because honestly, LEDs are not that expensive. You can get hundreds for not that much. So if I wanted to make an LED matrix, I could either buy a matrix or make one myself for not too much money. But having these 3 soldered together like this, once I remove this resistor, could be cool. They're already nicely soldered onto this board. And of course I can open up the other side. And most importantly, I got an interesting switch, which I get to figure out how it works. And then of course, I also get a nice cleanup job to do. So I make my usual point. This is not a cost-effective way to get parts, even those little metal poles. I'm keeping those in case they're handy, not because I know they will be. But I've learned a little more about how things can be put together. Seeing circuits, just taking things apart and seeing how they're put together can give you ideas on how to make your own circuits. The idea that if you have very low current, you can just use part of the frame to drive your circuit. Reminding yourself that batteries have internal resistance, so you could rely on that instead of including resistors in your circuit. Although I would still have resistors, at least minimal ones, and that one I suppose has a minimal one, enough so that it's not literally a short circuit. And we got more practice in using analytical techniques, deciding, oh, looking at what components are and aren't there, not dissecting the entire circuit, but just seeing, okay, there's these bulbs and there's wires, there's nothing else. So we check for polarity and we find polarity, and we can see there is indeed LED characteristics. Just look at the wires and you see how it's hooked up. Quite a few people dissected frogs in high school. I think this is pretty much the same thing, but more fun and less messy. So while I go clean this table off, I'll be seeing you.